In this video, we're going to look at our partitioning a segment worksheet. It was homework. We're going to begin with question 1. It says, given the points A, -1, 2, and B, 7, 8, find the coordinates of the point P on the directed line segment AB. And this point P has to partition AB into the ratio 1 to 3. So let's go ahead and start with step 1 of partitioning, which is to get a good idea of what this is going to look like. And it's part of the directions. We have to plot P along with the segment AB. So let's start with point A, which is at -1, 2. Let's go ahead and get that drawn on our graph. So -1 is on the x-axis, +2 is on the y-axis. That's going to bring us to that point right there. We're going to call that A. And then we'll plot the point B at 7, 8. So we have to go 7 on the x-axis and 8 on the y-axis, which will bring us all the way up here. We're going to call that point B. And we're going to go ahead and connect these 2 points with a line. And I'm going to cheat using my tool here to get a nice straight line. There we go. Okay. So we have our line segment AB. And we have to split this into pieces. So we've just finished the first step of our partitioning. We need to split this according to this ratio, 1 to 3. That means that 1 piece is going to be to the left of my partition and 3 pieces are going to be to the right. So altogether, I need to split this into 4 parts. Altogether, I need 4 parts. So in order to split the segment into 4 parts, I need to take the total rise and split that into 4 parts, and then I need to take the total run and split that into 4 parts. So we're going to go ahead and find that slope. And remember, the slope can be written as the change in the y values over the change in x values. This means the exact same thing as rise over run. So if I want to find the rise, I can count from point A how far it goes up before meeting point B. So it goes up 1, 2, 3, 4, 5, 6 spaces. So the change in y is 6. And then let's go ahead and find the change in x, the horizontal change. So from point A, we count over 1, 2, 3, 4, 5, 6, 7, 8 spaces before it reaches where point B is. So we have a rise of 6 and a run of 8. And our job is going to be to take this rise over run and split it into 4 equal parts. So we're going to take the rise 6 and divide that into 4 pieces. And we're going to take the run 8 and divide that into 4 pieces as well. Let's see what this new slope is going to look like. 6 divided by 4, if you do that in your calculator, is 1.5, so 1.5. And 8 divided by 4 is 2. So between each step, I need to go up 1.5 spaces, and to the right, 2 spaces. And if I do that 4 times, I'll split this in exactly 4 pieces. So there's my first one, up 1.5 over 2, up 1.5 over 2, and my last up 1.5 over 2 brings me right to B. So I can see that I've split this into 4 equal parts. Now, the partition has to be at my ratio of 1 to 3. So I need one of these parts to be to the left of my partition. So starting at A, here's 1 piece, 1. And then the other 3 pieces are going to be to the right of my partition. So there's the other 3. So that means my partition is going to be right here, P. Okay? That's the dot that represents my partition. Let me do it in another color. There we go. That dot right there. So 1 piece is to the left, 3 pieces are to the right. I have my ratio. Now, I can see where that value is because I'm okay with counting by 1.5s, but not everybody is, which means in order to get a good idea of where this is mathematically, what we need to recognize is that from point A, we have done 1 jump. That's this 1 in my ratio. And then the other 3 happen after my partition. But to get from point A to my partition, I have to make 1 jump using this ratio. So 1 jump from point A. So if I know the coordinates for point A, which I do, then all I have to do is use this ratio once to change my coordinates, and I'll have the coordinates of P. So the coordinates of A are that -1, 2 that we started with in the problem. And I have to use this ratio, 1.5 over 2, to change these coordinates. And all I have to remember is that 1.5 is going to change my y value. So positive 1.5 underneath my y value of my coordinate pair. And the 2 is going to change my x value. So the 2 can go under the x value of my coordinate pair. If I make this change, I will end up with point P. So -1 plus 2 gives me +1. And 2 plus 1.5 gives me the number 3.5. And this coordinate pair, 1, 3.5, is the coordinate pair of my solution in this partition. My partition right here is over 1 and up 3.5 spaces right there. So we have found our partition. Let's go ahead and take a look at question number 2. For question 2, they didn't give us a graph. So they just said find the coordinates of P so that P partitions segment AB on the ratio 5 to 1. And they did give us coordinate points for A and B. Now you can draw this on a graph if you want to, but it's more important for me just to be able to see this as a segment so I can get a good idea of what jumps are happening. So I don't have to put this on a coordinate plane as long as I go ahead and draw a representation of this line so I can get a good idea of what I'm doing to split it into pieces. So let's go ahead and take a look. If I call A this dot right here and say it's at the point 2, 4, I don't actually have to draw it on a graph. And then B, we're going to call it this dot over here, and we're going to say that that's the point 8, 10. And I'm going to connect these with a segment, just like before. So let's go ahead and get this guy, make it red like my ink. Here. So there's my segment, A to B. All right. Now that I have A to B, and I know that A is 2, 4, and B is 8, 10, I know that I have to split this into pieces according to this ratio, 5 to 1. So I need 5 parts to the left of my partition and 1 part to the right. So altogether, I know I need 6 parts. So what I'm going to do is I'm going to go ahead and estimate what that's going to look like on here. I don't have a coordinate plane, so I don't need exact jumps. I just need to kind of get an idea of what splitting it into 6 is going to look like. So let's go ahead and estimate that here. Maybe 1, 2, 3, 4, 5. Oh goodness, I didn't space those out very well. Well, that's split into 6 pieces. Maybe I'll just move some of these over a little bit. There we go. Okay. Now I have the advantage of being able to do that on a tablet, whereas you guys can't do that on paper. But this is just about splitting into 6. It's not perfect, but again, it's not on a coordinate plane. It doesn't have to be perfect. But I can see that I've got 6 different pieces on this segment. Now, in order to get this ratio, 5 to 1, I need 5 of my pieces. Whoops, let's leave that there. I need 5 of my pieces to be to the left of my partition. So 1, 2, 3, 4, 5 pieces to the left, and then only 1 little teeny piece to the right, which means my partition is going to happen right here at this point. So 5 pieces to the left, 1 piece to the right. There's my partition. Now, in order to figure out exactly what the coordinate pair for this is, I do have to figure out how to chop my x values into 6 parts and my y values into 6 parts. So I do still have to find the change in y and the change in x. And instead of being able to see it and count it on a graph, I can use my coordinate pairs to figure out what that change is instead. Because change just means the difference. How far apart are these numbers? What is the difference between them? And difference means subtraction. So all we have to do is use subtraction here. So my job is to find the change in my y values and the change in my x values. Ignore that email, we don't need that. So to find the change in my y values, I want to find out how far apart these numbers are, 10 and 4. So I'm going to do quick subtraction, 10 minus 4. How far apart are these? They are 6 spaces apart. So my y values have changed by 6. And moving from left to right, they've changed increasing by 6. So I always take my final numbers over here and subtract the numbers I start with to make sure that I get the proper direction. So 10 minus 4, my numbers have increased by 6. Let's see what happened with my denominator. So my x values, what's the difference between them? So here my x value is 8. It started as the number 2. So what's the difference between 8 and 2? Well, that changed by 6 also. So my rise was 6 units, the change in y values, and the x change was also 6 units. Now my job is to split this into 6 parts like I figured out up here, which means I have to take each of these numbers and divide it by 6, which is going to work out really nicely for me because 6 divided by 6 is just 1 over 1. So each step I'm only changing my x and y values by 1. So my job is to figure out what that change is going to accumulate to if I do it 5 times. Each jump here is going to change my x and y values by 1, and I need to jump 5 times. So I'm going to start with my a value, which was my a coordinate 2, 4. And I need to do 5 jumps to get to my partition. So 1, 2, 3, 4, and then the 5th one brings me right here. So 5 jumps from 2, 4, which means I'm going to take my a coordinate here. Oops, I just want to take this part. Just kidding, we'll write it again. My a coordinate, 2, 4, and I'm going to use this change for my y values and my x values 5 times. So my first change, second, third, fourth, and 5th. And after all 5, I'll end up at my point P. So my first change is going to change the y values by 1 and the x values by 1. My second one is going to change the y values by 1 and my x values by 1. And each jump that I do is going to add 1 to my y values and to my x values, according to that ratio up there. I add 1 to my y and I add 1 to my x. So I need to add 1 to my y's and my x 5 times to find my new point. So let's see, 2 plus 1 plus 1 plus 1 plus 1 plus 1 is 7. And 4 plus 1 plus 1 plus 1 plus 1 plus 1 is 9. So the point 7, 9 is going to show me exactly where my partition is supposed to be, because it's 5 jumps away from A, and each jump brought me 1 space on the y-axis and the x-axis. All right, we're going to go ahead and do question 3 in the next video.